All right, I'm just going to give you a few hints. Do the best you can with these. If you still need more help, Dylan, let me know. So, perimeter problems. Anything you want to do with a shape, you want to draw that shape. So this is talking about a rectangle. Wow, that was a terrible rectangle. And you also want to look up, if you need to, the formula. So perimeter is 2 times the sum of the length and the width. I'll let you figure out how to fill all that in properly. 2 unknown quantities or unknown quantities. There's a couple different ways you can do this. In general, what you're thinking of is there are 2 things usually that are added together, and one of them has more than the other or less, and then they total whatever it is. A lot of people think of these problems as a unfair. So I'm going to start with this one a different way as well. An unfair means that one has more than the other or one has less than the other, and what you should do is make it fair. So that means give it back. So unfair, it's going to be the total and plus or minus depending on what it is. If it is more, you're going to minus it. If it's less, you're going to add it. Whatever's unfair. And then what you do is divide it by how many people you have. In a lot of cases, it's 2. And that's what people are like, oh, I'm just going to take this answer and divide it by the 2 people. That almost works except for that extra part. You can't have half of something. If you were doing this problem here, you're not going to have half strikeouts. You want to be careful, though, that the problem does not also tell you something like one person is twice the other or 3 times something, because that changes what you're dividing by. You want to think about how many people that would be. If someone is twice the other, that means there's 3 people. If someone is 3 times the other, then there's 4 people in there. So you got to be careful about doing it this way. For some people, this is like an intuitive method. Percent problems are always dealt with a percent increase. So 100% plus some other percent, or a decrease, 100% minus some other percent. And then it is multiplied always by the quantity. And then what happens is, after that happens, you get your new value. And you can think about this as like getting a raise. So 100% of my pay plus a 10% raise. I multiply it by my pay, let's just say $650. That would give me my new pay. As with any percent problems, all of these become decimals. So 650 times 1 plus 0.10 or 1.10 would give me my new pay rate. So you want to think about percent problems in that manner. I'm not going to talk about the money problems because you just did those as a mixture. So we're going to move on to the next ones. Okay, motion problems. There's tons and tons and tons of motion problems. What these are like the train traveling in the same direction, the airplane flying in opposite directions, blah, 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 blah. Most of the time what you're trying to think of is how does this fit into the distance equals rate times time formula. Be careful about what it's asking you to solve for, because it may not be what you're actually going to do. When you're talking about same direction, though, you want to set these things equal. Because they're traveling the same distance, or they're traveling the same time or something like that. And it's based on the formula that we did before when we isolated variables. Distance divided by time equals rate if it's saying they have the same rate of speed. Distance divided by rate equals time if they're talking about they traveled the same amount of time. So same direction means something is the same. You have to decide which one of these is the proper formula to use and set it up accordingly. Angle measures, or any kind of geometry problem, you want to know the total angles. So like a quadrilateral has 360 degrees, a triangle has 180 degrees. Anything else you'd probably want to look it up. I honestly don't remember them. And maybe draw a picture to see what it's thinking about. It doesn't have to be accurate. You could still draw an equilateral triangle in here. It doesn't matter, but you in general have three angles: a small one, a middle-sized one, and then the large one. And that's how you want to think about it. So as you set this up, they all add up to be small plus middle size plus the largest angle equals 180 degrees. I'll put an arrow in there. Any other angle problems like supplementary or complementary are based on what it is. I'm just going to try and write this in here. Supplementary is 180 degree sum. Complementary means they add to 90 degrees. So these are fairly simple as far as like types of angles. Supplementary is a straight line, it's 180 degree sum. Complementary is a corner or a right angle, they add to be 90. In this case, they're telling you what two numbers to add together to set it equal to 180. It's a nice, pretty, easy, simple problem. Good luck, and we will talk about all these again many, many times. I love word problems.